Yo, yo, yo. What's up, Derek? Glad you're back, man. Always love these streams. Appreciate it. It feels great to be back as well. Okay. So we're gonna start slow today. I just need to get into things again. I haven't looked at this project in 3 weeks, I think. But now it's back to a regular base again. So stream every Monday to Friday. And let's see if we can get this water working. Hope you had a wonderful summer, by the way, Derek. Okay, so let's see where we're at, if the project is even running. I remember the last thing we did was to try and get the water system to work in a threaded way, and it turned out to be a little bit of a bigger problem than I anticipated, mostly because of the way we have decided to store the data. Let's see here. Yeah, exactly. So it's this error right here we're gonna have to dive into. What's up, Lemnine? Who is this poor bastard and why is he deforming the space-time manifold? I have no idea what that means. Are we talking about this? Poor bastard, and this is the space-time manifold. Yeah. It's just a little dude trying to terraform some terrain, so not the space-time manifold. Okay, so this error, like, if I recall correctly, it's like this. We have a fluid simulator that works, but it takes a lot of time. We want to offload its work to a second thread, which should be pretty straightforward. But the data we're working with is stored in a texture 2D, and you can't access, you can't read and you can't write to a texture 2D on a thread that is not the main one, and that's the problem. Yo, what's up, Fabic? Hope you had a great summer, and welcome back, welcome back. Okay, so I'm a little bit rusty, so it doesn't feel too great getting back to it with a big problem like this. But hopefully we can just fight through it. Finally some quality content. Appreciate it. Hopefully. Well, let's put it this way. We're gonna start slow today, real slow, just to get back into it. But hopefully it will still be some quality content. So, I wonder how I want to move forward here. If we take a look at, what is it, terrain data type. So this, yo, what's up, Harukanan? Yes, I'm back. Hope you had a wonderful summer and hope that foot is okay. Hope everything got sorted out with that one. Lemnin back. Okay, welcome back. So I was just saying before the ad break that it's a poor bastard, but he's deforming terrain, not the space-time manifold. Okay, so we have everything terrain data related is stored in a texture 2D, and this is the data we're storing: height, foliage. Then we have 2 unused channels. Then we have water previous, water temporary, timestamp. And the reason that we have this in a texture 2D is because we want to use it on the GPU as well as the CPU. And texture 2D has always been a good abstraction layer, and it has worked flawlessly. But as soon as we introduced threading, that's when the problems started. And that's what we have to sort out. And it feels like we're gonna have to do some... I guess we could hack it in sort of a way. So when we start the fluid simulation, we could take copies of all the different terrain patches, send it to the thread, work it out, get it back, and then put it in a texture 2D. That would be the most straightforward way, but it would be far from the best solution because we're gonna create a lot of extra garbage. But I'm leaning towards doing that, see how it works, and then we can maybe improve upon it. I think we're gonna have to do some pretty big changes in the base implementation here. Yo, what's up, Kendo? Hope you had a wonderful summer. Harukanan, well, I got rid of the cast last week. That's good. Won't be able to put full weight for another week. But I have a light at the end of the tunnel. What is this light at the end of the tunnel? But hey, getting rid of the cast is still great. So I guess you didn't do much swimming this summer. Been there. So basically we have this flow here. Let's see here. Action, terraform. As soon as the player clicks at a spot, we terraform, we apply the terraform brush, and eventually we end up in terrain data container, and we end up in a not the prettiest... Let's see here. No, actually, we end up in terrain patch, alter terrain data, add fluid, and this is the threaded one, I think. Yes, here we start the thread, and this is where it all gets screwed up. Ah, fuck. Hopefully it's not a train, but that I might be able to walk on my birthday. Yeah. I'm rooting for you. I'm rooting for you. Ooh, okay, so action terraform. Yeah, so when we click at a spot on the terrain, we get the terrain patch that we clicked on, and that's the one we're adding water to. So one could think that we just take the data for that terrain patch, make a copy of the data, send it to the thread, and do all the work. The problem with this is that our terrain, right now it's just one big patch, but that's not how it's going to be eventually. We're going to split it up into multiple patches, so that means that we need to copy. Yeah, now it looks like this, but yeah, the idea is that we have patches like this. But let's say that we add water to this point right here, it starts spreading and the thread gets to this patch. So we need to take a copy of this data as well. And yes, we're gonna have to do copies of all of these. I don't know how to approach this. And it all comes down to the fact that texture 2D and threading Unity. Yeah, that's not the one. Have I watched? Grab the color data, start the threads, wait in the main thread. I don't want to do that. Yeah. Yeah, like I've developed this system like with the idea that we're gonna be able to utilize threading pretty heavily, because we can take another example, terrain data type. We can take another example. So height, for instance. Or let's be more general about it. I've imagined that my AI agents, so the creatures, they will use the terrain data pretty heavily when they walk and such, to figure out like what is the quickest way from point A to point B using the terrain data. And I've always imagined this being done on a separate thread, right? But if we store this data in a texture 2D, we won't be able to do it on a second thread. So that's just another problem. So everything points towards using a texture 2D here. That is probably not the best idea. So if we move away from texture 2D, then we pretty much make the threading work pretty good, but now we have a problem of when and how we want to feed the data to the GPU. With the current solution, height doesn't really, when we want to make everything pretty, we're pretty much gonna need height on the GPU, because if we have two vertices that are close to one another, but the height difference is greater than some threshold, then we want to render that part of the mesh as stone, I think. While if it's not a big height difference, we want to render it as dirt. So we definitely want this on the GPU. For like when it comes to our grass shader, that's purely done on the GPU, so we want this data on the GPU as well. Water is gonna need, yeah, we need it on the GPU, but I wonder, let's see, Unity material. Float array. Like, I'm wondering if we could drop texture 2D. We're gonna lose a lot of convenient methods, like the blit we're using, but if we could work with float arrays instead, I don't know, Unity shader float array instead of texture. Like when you work with textures as well, you get a lot of like when we fetch values from a texture, you can get interpolation. So but I don't know if I think we might be using it in some parts. Yo, what's up, JD? Been a minute indeed. I've had, what is it, 3 weeks of vacation, I think. Hope you had a wonderful summer. Selecting a single component from a handful. I don't know. So we would basically be using storing it as a float array instead of a texture, and converting the UV to a two-dimensional, or one-dimensional index. Yeah, I don't know. Yeah, we create a terrain fluid solver instance. We give it terrain patch start and start fluid amount, and then we call start on it. One sec. Yeah. Okay, what about... No. So the problem... Yeah, we get to a problem here, right from the get-go, I think. Clear data. Because in clear data here, we want to do terrain data, clear data, get data array, get pixel data. Fabric. How about having a temp texture cached that will be used to send the data to the GPU and normally store the data in a float array? Let's see here. Yeah, I'm wondering, it's probably something like that we're gonna have to do, I think. So if we think about it like that and moving forward, and we look at water specifically here, and let me try and explain like my thought process here, because when I implement this solution here, I also think about what information do we need when we want to render this in a pretty way. So if we have this data, that's water, that's like at a given point on this grid, how much water is at that point. And yeah, that's pretty straightforward. Then we have water previous here as well, and that is how much water did we have at this point in the previous state. And the idea is that timestamp together with water previous and water, here we can use these three together to animate water change, so filling up the water, and we can do this on the GPU side. So we're gonna need those three to animate it in a nice way. When it gets to all of these four, I think it's only water temporary that we don't need on the GPU. This one is used during the solver. So yeah, like the most straightforward way, if we want to do it, if we still want to rely on Texture 2D, is that we have on the CPU, we have these four in float arrays, and then we also represent them with a Texture 2D. So we just double the amount of memory we use pretty much on the CPU. So the thread solution or the fluid solver use these represented on the CPU, and at different stages in the threading. So we divide the threading into three different stages, and after each stage we take what we have and send it to the GPU. Maybe. Fabi, you can set it up so the texture sent to the GPU is the size of the editing circle that divided between chunks if needed. Yes. Okay, let's see here. Let's see. Definitely. One sec. It bothers me quite a bit because, like, when we started developing this fluid solver, we did it using custom classes and structs and whatnot, fluid points. And then when we had that in place, because it was easier to debug, then we moved over to using Texture 2D, and then when that was done, we moved. We started trying to implement it as using a thread, but now it seems like we can't use Texture 2D. Like, maybe it was foolish of me to assume that we could. So now it's almost like we're digressing again, because we're gonna move back to some custom structs again, I think. Because I think, like, the best solution is probably to use a custom class for these four things, do it on a thread, and when it's done, we just put it into a Texture 2D, and then we call it a day. Yeah, that's probably how we're gonna have to do it. But then again, we still need this data. We still need height data on the thread. So yeah. Yeah, okay, so I think, yeah, I'm pretty sure what we're gonna do is, we have terrain data container. Right here we have data as texture 2D array. We're gonna change this data to float. A float matrix, I think. And then we're gonna have a texture 2D for the data that we need to send to the GPU. Yeah, we're probably gonna have to make it like that. But let's see here. So rename terrain data container to terrain data. We're gonna create a new class that is called terrain data, and we're pretty much gonna take all of this logic, rewrite it, so behind the scenes we use a float matrix, and then we have some methods for repacking it into a texture 2D when we need it. Yeah, that's probably what we're gonna do. So yeah, this is going to add a lot of, like, the footprint of the data is going to be quite a lot bigger, but it should be okay. I just wonder, generate texture content. Yeah. Now it should be pretty straightforward. Yeah, let's do it. Let's write some code. Because if we implement a terrain data class, and when that terrain data class is done, we just jump over to terrain patch, change this one to terrain data. It's going to use the same methods and such, so hopefully we don't need to change too much here. Yeah. Yo, what's up, Geralt? Good morning, good morning. Hope you had a wonderful summer. We have so many classes here which are like artifacts from old systems, and now we're gonna add another one, terrain data. Yeah, I think this is how we're gonna do it. And the thing is, so like if we take a look at the texture 2D and we take a look at the method get yeah, this one. So like we actually, like, the data in the textures are native arrays color 32. So the only thing we're gonna maybe we don't get that much of a extra data footprint, because like the only thing we're gonna do here now is that we take these native arrays and we instantiate them ourselves, and then when we start when we create the texture 2D, we just make the texture 2D arrays point to those arrays basically. So it feels a little like a hack. Let's try it. So we're gonna do this. And this is, yeah, this is sorta what you mentioned, Fabric. So yeah, I think this might work. Oh, nice to hear, Geralt. Nice to hear. I'm taking a few days to relax. Love to hear it. So I haven't been. I think I had a 3-week vacation now. So before today, I haven't actually looked at this code for 3 weeks. And just before I quit for the summer, we noticed that if we want to do the water system on a separate thread, we can't use texture 2D because that class doesn't work with threading. So we're trying to get around that fact, and I think we might be able to here. So yes, we're gonna store it as private. Can we do? Yeah, we're gonna store it as native array. Here's the next part. Do we want to store it as native array color 32? I think if we're gonna see, color 32 Unity. If we're gonna do this, we might as well do it with a custom struct, I think. There's really no reason to work with this one. But, oops, I think, what did I do? There. I think we want to do, I think I want to keep it as color 32 for now, because I want to make the step towards this new system smaller or more. I want it to be as similar as the old solution. So we're gonna wait with that one. Let's keep it color 32 for now. So color 32, so we have a native array of color 32. So each of these store 4 data values, RGBA. And then I wonder if we want to make this into an array as well. And we can name it data. Yeah, this is probably what we want to, let's see here. Use custom struct instead of, or maybe not even custom struct, use custom struct or byte instead of color 32. We want to keep this one. We want to do this. Instantiate data is going to look a little bit different. So what we do here instead is data is equal to new native array color 32, and we want to start it with a specific size. Terrain, Oh yeah, we also want to do this. I always forget. Namespace. Yo, what's up, Robert Pattinson? Yes, I am. Yes, I am. Hope you had a great summer. Okay, so instantiate data is going to be a little bit different this time around. It's going to be native array. And then I wonder, yeah, we want to do this one, I think. So it's pretty much yeah, we take the last type, so which is timestamp, and then we check what's the texture index for that one. So we create, yeah, this is great. Otherwise, what do we do here? Yeah, here we instantiate the texture. I wonder if we can do it like this. So private texture 2D array as well. Data texture. Okay, so we actually want to do textures is equal to new texture 2D data dot length. Then I wonder if we can do. Okay, this is going to be the big if here. Roy Patterson, I'm learning Rust and I miss C#. So how is, like, I've only heard good things about Rust. Isn't it as enjoyable as C#? Data textures. Okay, so this is the. So basically, what we do here is we create a native array of color 32s. We're gonna have to instantiate those as well, and then we create an array of texture 2Ds. And what I want to do now here, like, worst case scenario, we're gonna have to do it like this, so it's gonna be double the memory. We're pretty much gonna represent the same data in two different places. But what I wonder if we can do is, can we make these textures point at these arrays? So these textures are basically just texture 2Ds that points to these arrays. Use a switch then, Fabric? What do you mean? And Robert Patterson, I'm at the beginning right now, didn't enjoy it yet at all. It's been a while since I learned a new programming language, but I remember, like, usually, like, the initial time or the startup time when you learn the syntax and stuff like that, I've always enjoyed that, even though it turned out that I didn't enjoy the language later on. So if you don't enjoy the beginning, that doesn't bode well. Oh, now I get it, Fabric. like I said, it's going to be a slow startup period here. But yeah, okay. Hope it's a big if. Hopefully it will work. Yeah, I think it won't work. The texture holds its own color array. Yeah, that sucks. Yeah, good luck with the tipping of toes, Robert Pattinson. Hopefully it will get more enjoyable. Texture 2D Unity. When we create a texture here, what kind of constructors do we have? But if we do yeah. Or could we okay, so what about this? What if we do it the other way around? So we instantiate the data textures and then we fill up data with pointers to this one. Could we... Whoa. What if that works actually? So... Because I think what blocks us from using this on the thread, or I hope, is when we do this call. I think it's this call that fucks it up. So what if we do this call? What shouldn't that be possible? So if we have this, and then we have private native array color 32 data pointer, maybe pointers, and when we instantiate the data, so we create one texture here and then we do data pointers is equal to new native so what if we just do it the other way around? Instantiate the texture and then we do data pointers I is equal to, can we use get data array? Type or just data I get pixel data so we create the textures, we let them, like, are we blocked? Let's just try it real quick. So we had an error at line 33. in, what was it, terrain patch. So when we call clear data here, for each we call clear data. So we call this one here, we do get data array, and get data array, get data texture. So what if we just do return data pointers type dot get texture index will we get the same error if we do it like this? Is this just a, like, can we get around the texture constraints by doing this? I wonder. Let's just do a quick test. This feels extremely unsafe, however. But as long as we keep that in mind, and actually I want to try this with just using one patch. Yes, we get an error still, but now we get it at a later, yeah, now we get it at 36 instead. So 36. Now we get it at set data, because in set data we do, why do we get it here? Terrain data container 95, get index. Yes, because here we go. Here we try and read from the texture again. So this seems to work actually. So the only thing we do is our data is texture 2D, but when we create a data, we also create pointers to that data, and this allows us to work with the data on a separate thread. Feels extremely unsafe, but this might be the way. Let's see here then. So instantiate data, data pointers, so I guess we pretty much just want to rewrite all of these methods in such a way that we use this one instead. And then we're going to have to set up, we're going to have to be real careful here, and for each method we really need to think about how like what kind of race conditions, and on and on and on. So where do we need to set up like boundaries and stuff like that? But could it actually be as easy as this? So yeah, just to reiterate, instead of creating the data as native array color 32s, we create the texture, let it, or the constructor of texture 2D, create these native arrays, and then we just set up a pointer to them. Oh well, let's see. Okay, so yeah, so pretty much if we, yeah, this one is gonna have full control over the texture 2Ds. So as long as we make this thread safe, like every entry and exit point into and out from this class thread safe, it should be okay. But that also means that we're gonna have to do, I really hate, yeah, so we're gonna use array of single colored channels instead of a texture 2D, I think. So it's gonna be a 3D texture, I think, eventually, and we're gonna work with bytes here instead. I'm pretty sure. But we're gonna need a private int width, private int height here, because a call like this will also, if we do this call from a thread, we're gonna get a runtime error, because like you can't call, like the full texture 2D is thread safe, or yeah, we can't work with any of the methods in texture 2D from a thread. So we're gonna need to keep all of this as, or we're gonna need to have like threadable attributes for everything in texture 2D that we need to use. Yo, what's up, PG King? Yeah, it's been a while indeed. 3 weeks, I think, since my last stream. Hope you had a wonderful summer, and welcome back. So yeah, when we create these, instantiate data with height, let's jump to that one, and we also just want to do, so first of all we want to do this, width is equal to width, this dot height is equal to height. So in bounds we just change this one to width and height. Get data information. Yes, get resolution. Yeah, this one, this get data texture, do we use this one? No, we don't, right? Get data array, or actually, is it F12? Yeah, F12 and F12. Do we actually use this one here? That's unfortunate. Yo, what's up, E-Dragon? Good morning, and welcome back. Hope you had a wonderful summer. Okay, so here we have a method call that returns the texture 2D. So if we keep this method, then we break the one rule we had. So this means that we actually can return the texture 2D, and that means that we have an exit point that is not threadable, and how are you doing, my guy? Had a nice summer? Yeah, I'm doing great. So I had a good summer, no complaints. But it feels good to be back. I like what is the word? I like to have routines, and I haven't really had any routines during the summer. But yeah, it was good. How about yours? Okay, so what we do here is that we take the material that renders the terrain, and we set up the texture in that shader. And we're gonna have to do this, so we're gonna have to keep this exit point. So my question then is, actually let's put it like this for now. Note not threadable. Get data array, here we return data pointers instead. So get data array, get the index, channel index, that's good. Get data, yeah, good. Set data, yeah. Did some traveling, Poland and Denmark, nice. Went to check out Rammstein in Copenhagen. Oh, nice. I've never seen them myself, but I have friends, and my father loves to watch them live. I've heard that their live performance is incredible. Because we're talking about the band, right? Okay, so here's another thing. As soon as we do apply data here, that means that we're actually changing the texture 2D. We're sending it to the GPU, so we're calling a texture 2D method. So this, if apply is true, we can't do it from a thread. So just to make sure that it's a bit more thread safe, or to minimize the risk of running into problems, I'm thinking of making this method, this and this method, not apply it. So we're gonna create a separate method for applying the data later on. I'm pretty sure. So this one, yeah, we're gonna take this one, and we're gonna put it here, I think, and we're gonna put a similar note. E-Dragon, the live performance is crazy fun, such a show. Yeah, so I've heard. Maybe I should try and watch one of their performances before it's too late, you know? They're pretty old, right? Okay, so set data, we're gonna remove this one, we're gonna remove this one. Get index. Yeah, that's good. Set data. Get data array is okay. Okay, good. Oops. Apply. Let's do this. Alter terrain data blit. Yeah, this one is never gonna be threadable. Instantiate data. Okay. Vocalist is 61 years old. Oh, that's still younger than I thought. Like, I remember listening to them when I was like 12, and I remember them being quite old back then, but 61, that's no age. But yeah, okay, they are not young anymore, but still. So I hopefully still have a couple of years to watch them live. Okay, I think we're gonna have a lot of errors right now, because I think we call apply a few times in the threaded solution. Let's see. Or I thought. Set data, move data. Yeah, we have apply here. If apply. Okay. Okay, so it's these we have to be careful with. So we can look at it. So we have step 1 here. Finish step 1. Move data. Okay, so it's this one I want to watch. Let's see here. False, false, false. Yeah, I think we're good to go, actually. Wonder. So we start this one, then we start this one. This one is done on a separate thread. Let's just take a look. We create this one, and then we call calculate stable fluid state. Clear clear data. Move data. Alter data. Okay, here we have a problem, because here we have apply data true. Okay. Okay, so what I eventually want to do here, is terrain fluid solver. We're gonna create a fluid solver instance here, and then we're gonna start it, and we're gonna let the fluid solver instance run the first step down to here, and then we want the thread to pause, or like we want to, whatever result we have here, we want to pass it back to the main thread. So we want the main thread to be notified that we have now reached, or we have now finished step 1, and that's when we will apply the data. And when that is done, we want to start when that is done, we want to start the thread again, but now we want it to do step 2. So this, and all of this, environment controller. Yeah. So then we want the fluid solver to do all of this and this, and when we get down to here, we want to end the thread again and notify the main thread that the calculations are done, and you can now apply it to the GPU. So the biggest problem is this one, and the whole point of this one is that I want to visualize this. So pretty much step 1 is find minimas, like find points where the water, find reachable points for the water where water will pool up, and I want to animate this. Like I want to give feedback to the player that, yeah, you have started pouring water at this point, and the water travels to this point. And then this is, yeah, it's basically like this. So we're gonna have a thread. The thread is going to iterate this one. When it has found a stable state, we're gonna notify the main thread, we're gonna apply it to the GPU, we're gonna visualize it, and unless the player stops pouring water, we're gonna start the thread again and do this one more time, but with more water, and on it goes. I wonder. Okay, I want to do one thing before So right now all of this is threadable except for this one. So I'm gonna change this one. It's not gonna be threadable. So we put false here, and then we get back to finish step, visualize terrain data. We should be able to yeah, we should be able to visualize this. Let's see what happens. So let's see if it works. Okay. Have I overlooked something here? Maybe. Get transform can only be called from the main thread. What are we working here? Terrain patch 54. Okay, so we might have a few other things that are not threadable as well. Was it terrain patch 54? Okay. Okay, I learn more and more about threading and Unity. Like every minute it feels like. So okay, so transform. We can't even read most of the components' values from a secondary thread. Okay. That's rough, but I think it's okay. Ooh. And we use this one in Terrain Fluid Solver 182. Yeah, so this is just when we try to visualize it, because here we call position world space, and we even instantiate stuff here. But I wonder, let's see here. Fabric, you can click on the blue link in the debug window to get this exact line. Oh yeah. You're 100% correct. Appreciate it. Hopefully I will remember it the next time. How do I want to go about this now? I wonder, can we just hold? Let's do it like this. Finish step. We're gonna do debug log. I want to do those. We're gonna wait with this one. Okay, so now the next question here is, can we let's see. Can we when we start the thread, can we tell it, like, when you're done, call this method on the main thread? I don't know. That's not what we want to do. Stopped. I mean, we could probably, for each frame we could check the status of it in a coroutine or whatever. But I would assume that we have a nicer way to do it. So what I mean is, when we have done this, the thread is going to be isAlive is going to return true, and then we could check each frame here from the main thread. Is it still running? Is it still running? And if it's not, that's when we visualize stuff. But I don't remember the term for it, but like, I wonder if you could specify a method here that is called when the thread finishes, but I don't know. But then again, Terrain Fluid Solver, this could be a way of limiting. So just keep it at one thread. So I mean, like, the most rough way to do this would probably be to do private thread, and then we do this. Public static. Oof. Yeah, it's static. Do I want to keep it static? Yo, what's up, Love? Great to have you back behind the controls. Appreciate it, appreciate it. Yeah, we're doing a slow start today. Gotta get used to being behind the controls again. Yeah, okay, this is gonna be rough initially. It's gonna be rough initially. Yeah, let's just keep it like this, and then I wonder if we can do private coroutine fluid solver routine. And then we do private. So it's starting to look more and more like a singleton, but oops. And then I wonder, oh yeah, we need this to be mono behavior if we want to start coroutines. That is true. How do I actually want to structure this? Okay, let's do it like this. Public class terrain fluid solver mono behavior, and then we do public static instance, but we want to do it with Fabric, that is true, that is true. How about task async await? Yeah, let's take a look at that one. That might very well be exactly what I want. But let's see here. Task async await scenarios. Okay. Oh, that's beautiful. That is exactly what I want to do. But I wonder. Okay, so I should be able to do, let's go back a couple of steps here. So what we want to do, we want to do it here, right? Somewhere, is it this one? It has run. So can we do a wait? Async. Oh, fuck. Okay, so we want to work with tasks instead, right? Okay, complete example. Let's see here. Okay, let's see. So we want to make this one async. Just call the blah blah blah. Beautiful, exactly what we want. I'm a little bit... I wonder how this actually will work with the rest, if you know what I mean. No, it should be okay, right? Okay. So we make our fluid solver instance into a task pretty much, or our fluid solver task or whatever. Create it like this, and then we just do this. But I wonder... So would this be better? So if I understand this correct, never worked with tasks in C# before. But we, like, instead of using threads, like I guess this one uses threads behind the scenes, but we don't explicitly create threads, but rather take the task we want to do, wrap it with a task, and start a task instead. Let's see. One thing though. Mm. I'm just trying to apply this. Okay, let's see here. So add fluid here, for instance. Yeah, we want to make this into a task, and when that task is done we want to do something else. The only thing I wonder, how do we want to define this or order it or implement it in such a way that, like, we call this method and start it, but the rest of the game continues on, or the rest of the code flows as it should. Because it's basically, we want our separate thread to do some work, but when that thread is done, we want our main thread to pick it up and visualize it, basically. So let's see, do they have... Okay, beautiful. Getter can't continue until getString task is complete. Meanwhile, the control returns to the caller of get URL content length async. Control resumes here when getString task is complete. Oh, fucking beautiful. Let's see. I wonder, task. So we want to do so let's see here. Yeah, let's just copy this. But terrain fluid solver instance, do we want to create a new one? Maybe, might as well. This one we want to do a sync, and when we visualize it here, this we want to make we want to await this task, okay? But then again, I wonder, do we actually need... This one might be redundant in this case. So terrain fluid solver, add fluid as sync, private static void. I wonder if we want to take... So what if we take this one, put it here, and then it's just finish step. Yeah, we don't want to do those just yet. Terrain patch start, do we change? And I wonder if we can do void. What do we actually want to return here? Okay, so we just want to return task, I suppose. And then we can do, let's do, I wonder if we can do it like this. So could we do add fluid as sink? Here we do calculate stable fluid state step 1. Then we do something like this, step 1. String contents. As we await. So step 1, await step 1. Show step 1, and then we do task step 2. I wonder, await step 2, show step 2, and eventually we want to do it like this. So while something like this, while or is this insane? So add fluid as sink, calculate stable fluid state step 1. This is task, and add fluid as sink can't do anything else until step 1 is done. So we do await step 1, and control returns to whatever thread called this method. So that's going to be the main thread. And then when that is done, so this one is done, we get back here, we show the result, so it's the main thread that shows it. And then we check, is pour water still true? If so, we create a task that calculates the step 2 of this fluid solver. We can't do anything else, we await it, control returns to whichever called this one. When that is done, we show step 2. And that's main thread. And then it jumps back here. If we're still pouring water, we do it all again. If this works, or if we can do something like this, that would be beautiful. I don't know. So I would like to split this one into different steps, yeah. Finish step, finish step, finish step. So something like, yeah, let's move. Finish step. Yeah, we have stopwatch here as well. Oh well. So restart. To do, yeah. I'm just gonna put this right here for now. System timestamp. What was its time span? Elapsed, restart. Yeah. But we want to move these outside of this task later on. Yeah. I wonder how it will work with the stopwatch, however. We'll figure it out. Let's do it as 1 first. So task calculate stable fluid state is equal to yeah, it's actually this one I want to call a sync. Add fluid. And then we do await No, 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 no. Ah, we can do it like this. It's currently a mess, but let's see here. Okay, this is how we want to do it. So let's call this one, we don't want this one to be a sink, so calculate stable fluid state, void. Right, this one we want to make a sink, add fluid sink like it was. This one we want to, no, yes, but I wonder, so do we want to do await this, something like this? Yeah, that's how we want to do it, right? So add fluid a sink, and call client get string a sink. Something like this, then we call this return task. We need to, what is it? I wonder. Can we just do for now? Let's do. Yeah, because this is how we want to do it, right? So add fluid async, calculate first step, and then we want to wait on it. I just wonder how, if we don't want to return something, we don't, like, we are waiting for a value, but we already have a reference to that value, pretty much. So I wonder how we want to do it here. But I wonder if we could do... Yeah, I wonder if we could just do... let's do it like this. Private static task string calculate, or actually unvisited points. Hell yeah. Okay, so we're gonna do this. Task terrain patch int x int y and we want it as a list. Let's see. Calculate reachable minimas. Okay, so phase 1, calculate reachable minimas async. And what we do, I'm gonna wait with stopwatch for now. So we want to do this. We have start fluid amount as well. Let's put this one on the second line as well. Okay, there we go. Calculate reachable minimas async. And what we want to do here is let's see, yeah, down to here. We do this, we do clear data, move data, set data. And those are okay now. They are threadable, I think. And then we have final points. This we don't care about now. finding all reachable minimas. So then we have unvisited points here. So then we want to return final points, but we want to return it as a task, I suppose. Task T result. Do I really like... Okay, I just wonder, so if we do this, calculate reachable minimas as I'll do it like this. And then we do public static async. Yeah, so actually we can do, this one is not a sync, but we want to do task.run here, I think. So we want to do this. think I want to avoid... fuck it, let's do it like this. But I wonder... Wait. So, could we do... yeah, we can probably do... task.run. One sec. We want to do it... Yeah. If we do... this, that's pretty straightforward. Can we do... or... yeah... is equal to then.task.run. Is this actually how we want to do it? Doesn't feel too good. Okay, give me a different example. Or when we get to this one, calculate damage done, static damage result. Yes. So what do we do? When this one is clicked, async. We call this one. We get the result. Okay. Like, according to my current understanding, which isn't that great, I would like this one to be a sync, and I would like this one to be a sync, I think, because we want to wait on this one. Like, we want to do stuff here, and when this one is done, we want to utilize that result in different ways. But I don't know about this. Yeah, okay, so we should be able to just await it like this. Okay, beautiful. Oh, okay. Yeah, what bothers me here is, like, yeah, I would like to make this one a sync as well, and we want to await it, but we don't really wait for anything here, so Okay, give me the complete example. So let's see here. Fry eggs, sink. So this one is probably the one that is most similar. So let's see. Damage result. So yeah, list. We want to return a list of terrain patch, X and Y tuple. So let's see here. Calculate reachable minimas. We could probably do it like, yeah, we do this. var variable reachable minimas is equal to a weight. So it's equal to a weight let's see, task.run, and then we do it like this. I thought we had this one as a sync. There we go. Okay, so this is how we want to do it. Probably. But this one, reachable minimas, await, and then we create a new task and it runs calculate reachable minimas. Whatever thread called this one will continue its work until this one is done, and then we can do stuff here. Although I'm a little bit... It should be okay. This is how we want to do it, I think. Display damage. So we get reachable minimas. And then what we do is calculate reachable minimas. We don't care about step 1. Okay, yeah, so we want to move. Let's move this one to here. And then we do this. Order by, yeah, we want to do that as well. But now that's step 2, so it's okay. So then we can do this. Find minimas. Restart. So then we want to split up step 2 as well. Calculate non-overflow fluid amount per minima. We have a finished step prep here. We don't care about that. Okay, so honestly, let's just take this part, I think. Yeah. And then we do private. I think we want to do it as void here, if I'm... Yeah, I think. Calculate. Let's see, calculate. Let's do minimas. Yeah, this one, however. Okay, let's do... Yeah, I actually want to split this up more times than we have right now, but we're gonna wait with that. Just make sure this works and then we can try it. Let's call this final points for now. I'm a little bit worried about this one though. Okay, so fluid amount is just this one. It's a little bit of a mess, but yes, and also want to do this. A little bit worried about this one. I wonder if okay, so if it's bigger than 0, we set it to fluid amount. That's pretty much all we do. But final fluid amount, we use it there as well. Yeah, I think we're gonna move it in such a way that we do we're gonna move this one out here. And we're gonna do byte fluid amount. And we're gonna do something similar in calculate stable fluid state. So we have final points and fluid amount. What's up, Dustin? Okay, so now we have fluid amount here as well. Stopwatch, we're gonna remove those. This one as well. And finish step, we're gonna do let's do this. Okay, so we do calculate reachable minimas and we wait for it to finish. When it has finished, we finish that step, and I thought we would visually show it, but we don't. It's okay for now. And then we're gonna do all the last steps, and then we're gonna show it like this. Okay. So then we don't return anything here though, but that is probably okay. But what is the syntax in that case? So then we just do, can we just do await task.run calculate stable fluid state, and here we want to send in reachable minimas and fluid amount. That's about it. So then we await that, and then we do finish step 2. And we send in water here because we want to visualize water. Is this it? Okay, I want to try this. So basically, static async. So when we click on a point in the terrain, eventually we're gonna call alter terrain data, terraform data, and terraform brush. Right now the terraform brush type is water, so we're gonna call terrain fluid solver add fluid async. But I don't know. But we want to continue. So because this call is not awaited, execution of the current method continues before the call is completed. But that's what we want. Because, okay, so then we call add fluid async. And what this one does is we calculate fluid amount, do some stopwatch stuff, and then we await. So when we get to this one, we offload this to a different task, and then we return from this method. So this one continues on. I don't know. But when this one is done, we visualize it, or we just print this basically. And then we start this task and we await it. And when this one is done, we visualize it. I don't know. Let's try it. let's see what happens. I wonder. So if I make this one really big, are we actually doing this on a separate thread? Because that would be amazing. I wonder. We have some delay here. Ah, okay. Yeah, it might actually be. It's extremely quick. I wonder, I want to try. Let's do this. Let's add a fake wait here. Yeah, let's do it. So, let's do it like this. Await task delay. So that's one. Let's do 1 second. Then we do this. Then we start. We find this one. We add a wait here as well. Then we do this one. We add a wait here as well. What's up, ASD? Let's try this. Let's see. But because what I think, so we see a little bit of a frame delay or a lag spike or whatever you want to call it, and I think it's because of this one, because we're actually instantiating a lot of objects we don't really need to instantiate, but like it's just for visual feedback. But I want to see what happens here. So the idea is that this thread or this task will wait 1 second, but we won't notice it as we can still run around with the character. But the calculations will take some time. I think I also want to visualize. Let's see. So if we add one here, yeah, it's working. There we go. Okay, this is, damn, pretty good. Pretty good. Mm. Okay, I want to visualize some more things, I think, or do I? Like, the idea is that we're pretty much going to, like, when a player starts pouring water at a certain spot, we're gonna lock the player character, but we want animations and everything else to run without lag spikes. So yeah, let's see if we can add. Yeah, let's see if we can add some dynamic stuff here. First of all, finish step, visualize terrain data. I have to say though that what a beautiful way to do this, I think. Big fan. But yeah, let's see here. Yeah, I want to split this one up a bit more, so we're gonna do this. Yeah, let's see if... Let's see... Yeah, this is something like this is what it eventually should look like. I just need to figure out. Okay, let's see if we can get it to work with the final mesh. So the mesh we're supposed to use instead of these blocks we spawn. So basically here we alter texture data, but we don't really apply it just yet. Although I wonder... Okay, let's see here. Terrain patch. Yeah, I want to remove this warning eventually as well. But let's see. So terrain patch, we have a water mesh here. We set material texture, we set the texture, okay, that's good. But we haven't really... Okay. And the water material is... let's take a look at that one real quick. Terrain procedural water. Okay, so currently we just offset the mesh. And where do we do that? We do with update mesh, update all vertex data. pretty much want to do something like this. Although I wonder... Yeah, when we calculate stable fluid state here, I probably want to return every terrain patch that has been affected by this and then update the meshes. But eventually I think we're going to do it purely on the GPU. That might be the best option. We don't want to try that. So what I mean by that is, in the end here we do... Yeah, how do I want to do this? Let's do... Okay, so basically at this stage, all the data has been updated. We just need to apply it so that the GPU can access the latest data. And we just want to apply I wonder. Yes, we basically just want to apply the... we might do it in a costly way for now, I think. Update all vertex data. So maybe. Basically, at this point, we want to have a we want to have a list of each affected terrain patch. I wonder if that's what I want to return. So I do wonder, however, let's see. Final fluid amount. Yeah, so at this point, when we remove unvisited points, P, actually, when we add them to unvisited points, final points, yeah. When we add a point here to unvisited points, we also want to add it to affected points, maybe. So we have a list of all affected points, and I don't know exactly how I want to use it later on. But let's see. Because with the current implementation, I basically want to go through all affected points and update the mesh accordingly. But that's going to be costly, so that's something we would like to offload on the thread as well. But I wonder if that will be possible. Or actually, terrain patch. This work, yeah, this might be possible to offload, but yeah, definitely. Yes, we can recalculate the normals on the thread as well, I think. Because what do we do here? Terrain patch mesh. Then we have I would be very shocked if we could call this method from a thread, but we might as well try. So let's see here. Let's do terrain fluid solver. Let's add calculate fluid stable state, private, yeah, let's keep it like this for now. Update fluid mesh. And what I want to send in here is basically a list like this, final points, but we're gonna rename this one affected points. So when we're done here, I don't think we're gonna do this. Finish step 2. Comment this one out. Remove this. And then I want to do await task run mesh. Oops. Update fluid mesh. And we want to send something in here as well. But yeah, we're gonna wait this one. And then when that one is done, actually let's add restart this one here, await. Yes. So I want to make this one return this one. Yeah, and now it's the back to the old question, do we enter this one more than once per point, or could that happen? I don't think so. I'm pretty sure we don't. So, what do we want to do here? Is equal to this, and then we just send in affected points here. I think that's what we do. What we want to do. Inspector, thank you so much for the follow, appreciate it. Okay, so the algorithm is basically find reachable minimas for the fluid, so points where it can pool up, and then we calculate how much water can pool up here in such a way that it doesn't overflow. And when we have, so then we have a list of points where, and for each point their fluid amount has been updated, so we want to update the mesh for those points as well. And that's what we want to do here. And I'm going to be optimistic first, so I'm going to assume that we can pretty much do everything mesh related on a secondary thread, although I think that will not be the case. But we're gonna do as much work as we can on a thread and then just do the finalization on the main thread if it's possible. Where do we have it? Update fluid mesh. So for each affected points, so what I want to do here is p.terrainpatch.update. Don't we have access to this? Terrain patch. Yeah, this is what we want to do. PG King 9, are we working on the fluids? Yes, indeed we are. Like, we have successfully made it multi-threaded right now. After Fabric opened the world of task async await, which made it so much simpler than I initially thought it would be. So now it's just about, so now we're in the process of hiding all the fluid calculations. So we want the game to still run. Like, we don't want to get any FPS drops or lag spikes while we do these calculations, and it actually works. So that's good. And now we just want to alter the mesh as well. And when we have that in place, we want to make it pretty. And when we have that in place, like when I say pretty, we want to make it, we want to remove the jagged edges of the mesh. And then when we have that done, then we can finally start with the water shader. But that's still a few days away, I think. Okay, so recalculate terrain patch mesh at index. This one we want to do in that task, but currently this one is a private method. I think we're gonna make it a public. Yeah, indeed. Yeah, like I have too many tasks like in the pipeline or in the close pipeline. But I think we can manage. In fact, do I want to make this public? Yeah, let's do it public. So p terrain patch dot recalculate terrain patch mesh at index p dot x p dot y. Ooh, data index, that's true. This one is public, this one is not. Ooh, that is true. Okay, never mind. Private. Data index, here we do terrain data type dot water I guess we can just do it like this for now. So we recalculate the position, normals and tangents for the water. And then when that is done, I want to do something that is quite ugly, but I want to try and do this. So here I want to do terrain patch in affected points dot, what is it? Unique, distinct. Something like this. We don't need to array. Can we just do... No, we cannot. Group by p dot terrain patch. Select. What can we just do first? Select G first. And then we iterate through these because I want to do terrain patch dot, and we want to call not update all vertex data, I don't think. No, we want to do or actually is it that one? No, because then we do this. Update vertex data, update mesh. It's this I want to call. And we just want to do it on a water mesh right now. Let's do this. Update vertex data. And what does update mesh? Recalculate bounds. Okay. I think it's this one. I'm very skeptical that we will be able to call this one from a thread. And this one I'm almost certain we won't be able to call from a thread, but we will find out. Update mesh. Okay, because in terrain fluid solver we want to do tp dot update. Wasn't it? Something like this. Yeah, we will find out. Update fluid mesh. We're now calling it here as well. Okay, great. Yeah, let's try it. Let's run it. And I did disable... Yeah, so we don't spawn any boxes anymore. So that, like, what I'm hoping for now is that the actual water mesh gets altered. So I'm talking about, I think we have, yeah. So these meshes that are underneath the ground. I'm hoping, but we'll see, we'll see. Ooh. Calculate stable fluid state. Then we run this one, but this one, it doesn't seem to be... It might be extremely slow. I wonder. I wonder what happened with this one. Or if it's blocked or something. Let's just try and do... Let's try it, but not as a task. First of all, affected points. Let's see if that works. Or do we have a warning that is relevant to this one? Yeah, we'll find out. Okay, it actually works-ish. If we don't do it on a thread. Let's see here, step. Yeah, it's not too bad when it comes to the speed. But yeah, okay, so I think this task... I would have hoped that we would have gotten like an error or something. Wonder about this one here as well. Water 61. Okay, I think I know why we're not updating this one, definitely. But yeah. Yeah, I mean, update fluid mesh is also extremely quick. So worst case scenario, if we can't put this on a separate thread, I'm okay with that, because it's still extremely quick. Although, what the fuck is going on here? 127. Yeah, we definitely don't want to get results like this. A few things we need to fix here, but I think I know the cause for most of the issues we're seeing. So we should have water here as well. Yes, we do. The problem here, I think, is can we yeah, we're getting water here, but it's weird. But let's see. Yeah, when we alter the water mesh, we don't take the ground mesh into account, so the height of the ground mesh, which means that we get this weird looking water. So we need to fix that as well. It's still extremely quick. So like if we take a look at step 3 here, like this one is extremely, what do we have, 3 seconds. Basically what we do in update fluid mesh is that we take, for each point that has water that is affected by the newly added water, we recalculate the normal, and when we do that, like, we read all the neighbors of that point, how much water they have, so we can calculate the normal based on that. And then we do yeah, and then we also update all the, or we take, for each point in the mesh, we apply it as well, and then we also recalculate the bounds for the full mesh. So I'm pretty shocked at how quick this is done. That's very nice. So if we need to do it on the CPU, it should be okay, but I don't know. Yeah, so for instance here we can see that the terrain has a height of 82 and a water of 76. So we would like to set the mesh water height to 88 plus 70 here, but instead we're just setting it to 70, and that's less than 88, so the water is below the terrain. But first of all, I want to double check. Okay, so if we don't do this as a task, a async task, it works. So I'm thinking that our thread or our task can't access the data it needs to access, or not update the data it needs to be able to update. So it just stops. I wonder why we don't get any exception or anything like that. But so if we go to update fluid mesh, so I'm pretty sure this one doesn't work, because here we work with, so here we just work with a native array, I think, but here we work with Unity, the Unity mesh class, and I think it doesn't like that very much. So I want to try and do, let's take this one, we just move this one out and we put it after this one. We should be able to do this, right? In affected points, yes. So let's try and just do this. So the first part we do in a separate thread, the second one we don't. And let's see if we have any problems with this. Okay, this is okay, yeah, that's nice. Still a lot of time though. Or not that much quicker. Maybe. Beautiful. It's extremely quick. Okay, so first of all, I want to fix like this hole we have here. I know why we're not getting that one filled, and that's because when we create affected points here, we don't actually add the first point. So the minima that gets flooded first doesn't actually, we don't alter the mesh at that one, at that point, so we need to fix that. So I wonder, final points, unvisited points. Yeah, I think we want to add it here instead of while, or do we want to add it here? I wonder if this is a better way to do it. Yeah, let's try it. Okay, now that works. That's good. The edges are always going to look... Yeah, okay, we haven't made the water fully work just yet, but... Okay, there we had one that took extremely long, but I think that's okay. Yeah, I also want to block, so yeah, we're gonna get to that point later on as well, but like if we add water at a certain area, I don't want the player to be able to run to another area and add water there at the same time. But that's pretty much going to be locked by like game mechanics. But I think, and we're pretty far from implementing those right now, but I think I want to add a hard lock now anyway. So like we won't be able to create multiple tasks at the same time. We will only be able to run one task at a time. But yeah. Okay, but I think that's gonna be it for today. I think I'm gonna do 4-hour streams this week. And honestly, like, this feels way better than I thought it would. I thought it would be an extremely slow start, getting used to the code base again, but this went pretty smooth. So yeah, thank you so much for watching, everybody, and we'll be back tomorrow, and have a great rest of the day. Peace.